Let us learn in this video the statement of the remainder theorem and also the statement of the factor theorem. First we take up the remainder theorem. We know fx is a polynomial in x, and here goes the statement of remainder theorem. Let fx be a polynomial which is divided by x minus a, then remainder of the polynomial is equal to f of a. We take up the example which we had done earlier, that is, we had divided the polynomial fx is equal to 2x cubed minus 3x square plus x plus 5 by x minus 1 by the long division method, and we had obtained that remainder was equal to 5. Let us do the same problem without actually performing the division now, and we will apply the remainder theorem. Let's see how much is the remainder by applying the remainder theorem. Fx is equal to 2x cubed minus 3x square plus x plus 5 to be divided by x minus 1. First I make x minus 1 equal to 0 and get the value of x as 1. So according to the statement of remainder theorem, the remainder is equal to f of 1. Remainder is equal to f of a. Here a is 1. Remainder is equal to f of 1, and we get the value of f1 by substituting x is equal to 1 in this expression, which gives you 2 into 1 cube minus 3 into 1 square plus 1 plus 5, which when we simplify comes to 5. So this is same as the remainder of 5 by doing the long division method. This is the advantage of remainder theorem. We get the remainder directly without performing the long division method. Now from the remainder theorem, we come to factor theorem. This is the statement of factor theorem. Let fx be a polynomial in x. X minus a is said to be a factor of fx if f of a is equal to 0. In order to understand the factor theorem, we have to first understand what is a factor. Very simple thing, you all know. 2 is said to be a factor of 8. Because when we divide 8 by 2, we get the remainder as 0. We say 8 is completely divisible by 2. That is because there is no remainder. Remainder is equal to 0. Now I am making a statement that this particular factor theorem is a special case of remainder theorem. Factor theorem comes from the remainder theorem only. See which way is it? When we divide fx by x minus a, according to the factor theorem, the remainder will be equal to, according to the remainder theorem, the remainder will be equal to f of a. Now, if fx is having x minus a as its factor, then there will be no remainder. That means the remainder will be equal to 0. So we can say f of a will be equal to 0. So factor theorem has been proved to be a special case of remainder theorem when that particular remainder of fa will be equal to 0.